Okay, today, this is our objective: distinguish between a compiler and an interpreter, and to understand the difference between source code, object code, and executable code. We actually did this in the previous. Where does coding come in? Well, it comes into this whole idea of getting information to the right location in order for decisions, right? And those decisions, they can be made by technology, people. I say this very loosely, but there are lots of structured decisions can be made by a computer. You can just think of everything the computer does to operate our car nowadays where it never used to be. You should understand the difference between top-down design and why this is important. And you can also understand that this can be very expensive, and time can take lots of time to develop. But if you understand why we need this type of solution, then that would make sense. Bottom up. I gave a number of examples on this. Save some money, save some time, but the solution may not cover everything that you might need, but it may be well enough for this. A lot of upstart companies, the new information upstart companies, they'll start with this. They'll get some design, some business design that works, and then they'll just build on it. And then they get bought out, or maybe down the road they redesign it. Talked about programming. Purpose: solve a problem, get a solution for something. Like right now, years ago, before we had cash, people just bartered. They traded products, and they said, we can use cash to do that. Nowadays, we can move funds electronically. And what problem did we solve? Well, we solved the problem of getting robbed if we have too much cash, or we solved the problem of bad checks in some cases, maybe not entirely. So there's something we want to solve, and can we do that by developing software? And we talked about these terms, specifications, design, pseudocode, so forth. Now, topic for today: program development. We start out and we write source code. What do we write it on? Well, we already have a plan. Okay, does that make sense? We've gotten a plan. We did the pseudocode, the flowcharts, the design, all that stuff. So we already have a plan. Okay, and this could be in an information system also. Okay, we already know what we want to do, and so then we develop source code. We write that, as I mentioned before, in some language. Typically referred to as high-level language. There are some languages that are low-level, like assembler, where it's very close to being what the machine understands. We don't get into that in this class. Once the code is written, okay, it's called source code. Okay, then it can be compiled. You can take the source code and compile it, okay, into an object code. Okay, so the source code gets compiled in object code. Or it can be interpreted. When it's interpreted, it's like a compiler, but it's not left in the compiled form. So scripts, a lot of things on the internet, in browsers, scripts, they're just interpreted. You just run it once, and then you run it every time, or you execute it every time from the source code. Make a little more logic when we move down. So a compiler, if you're writing language in C++, you have to have a C++ compiler to compile it. And how do you compile it? You compile it to work on a particular operating system. So if you're writing an app in C++ for an Apple, then you have to have a compiler that will compile it to run on Apple's iOS. For Android, then an Android iOS. Get it? So it starts at a source code, but then you compile it into something that will work on a particular operating system. The next couple steps are easy. Source code's compiled into an object code. An object code is linked using software libraries into an executable code. That is what most software is on your machine. You might have seen programs with that exe.exe, like Microsoft Office, Microsoft Word.exe, that's an executable. Okay, Microsoft people designed it, okay, and they created an object code. The object code was then linked into an executable code, okay, into an executable code, which is what runs on the computer based on an operating system. Of course, once you get it compiled, test it, evaluate it. We have all these version numbers, alpha test, beta test, and so forth. Different levels before you can distribute your software. Now, this will be a little review, but maybe this will make a little more sense right now. Proprietary software is typically software that once you build the executable, you usually lease, or some people say they sell it, that software for people to use, and they cannot decompile it. They cannot take it back to this stage, make changes, and create it again. Because it's proprietary, you own it. Lots of software is proprietary. A lot of people are going to, instead of you buying, you get a subscription. And you pay so much, you pay so much maybe a month to use the software. Now this other category, open source, means the source is open. You can look at the source. They'll distribute. They'll give you the source. Then you can change it and make it any way you want. A lot of interesting things that go with this. There's a license with open source that tells you what you can and can't do with open source. You must, the key thing there, you must leave it open. I mean, you could try to sell it to somebody, but you have to leave it open so anybody else can look at it, so it wouldn't make a whole lot of sense to sell it. There's a whole world of applications that are also open source, and then there's a whole world of applications that are free. If you look at just two things, Apple's iOS works on Apple devices, but the Android developed by Google, who pays for that? No one. It's free. You can develop any kind of device you want and ask Google for their Android operating systems. Okay, you can just have it. It's free. They don't charge for that at all. It's just an interesting approach that we'll talk about a little bit more as we finish up the course.